Welcome to the course. The topic of this lecture is TCP/IP Protocol Stack Part 2. In this lecture, we continue the TCP/IP Protocol Stack. In previous lecture, we completed the whole TCP/IP protocol architecture, family members of TCP/IP. In this lecture, we shall be talking about the IP layer of TCP/IP. Basically about IP datagram and IP header fields. We already mentioned in the TCP/IP protocol stack, the IP layer is networking layer. The main responsibility of IP layer is routing of packets in internet. The other responsibility of IP layer is breaking of larger packets into smaller packets if required. This is called fragmentation. We already discussed IP layer provides a connectionless, unreliable delivery of packets. Basically, it is a datagram service. Routing of datagrams from one node to another node. Each intermediate node consists of routing table. On the basis of this routing table, it forwards the packet to the suitable outgoing link. Each datagram packet is independent of one another. There is no relationship between successive packets. So, it is not required to maintain any history at IP layer. It simply sends the packet on the basis of routing table. Each IP packet must contain the source and destination address. Destination address is required to reach the destination. And requirement of source address is because sometimes for some application an acknowledgement is sent back to source. IP layer does not guarantee delivery of packets. Some packets may get lost, duplicate packets may get generated, and packets at destination are delivered out of order. Next is IP layer provides some encapsulation, which we discussed in previous lecture. It receives data from transport layer. It can be TCP or UDP and adds a header of minimum of 20 bytes. Typically it is of 20 bytes. Sometimes it can be more, but it is rare. This header contains relevant information for handling routing and flow control and forwards it to the hardware or physical layer. This is the overall format of IP datagram. As you can see here, the first 5 rows are header. The next row, options, is optional header. In each datagram, header field is mandatory, but options is not. After that, the actual data that is going for transmission. Now comes to what are the fields in the IP header. You can see at the top, these numbers are bit numbers. It starts from 0 and end with 31, which means in every row there are 32 bits, means 4 bytes. There are 5 rows in header, so header length is 5 multiplied by 4 bytes is equal to 20 bytes. Got it? These are the fields of IP header. In first row, the first field is version. Next is header length. Next is service type and total length of packet. In second row, first field is identification, then some flags, and fragment offset. In third row, time to live, protocol and header checksum. Fourth row has only source IP address and fifth row has destination IP address. You can see source and destination IP addresses are 32 bits long. Next is options, which I already said it is optional field, and next is data. Let us see different fields one by one. The first field is version field, which indicates which version of IP is using. Means either IP version 4 or IP version 6. It is 4 bits long. Typically, IP version 4 is using, but at some places IP version 6 is also using. Next field is header length. It is also 4 bits long. It shows the size of header. If header contains only the 5 mandatory rows, size of IP header is 5. And as I told, if it contains some optional field of header, the size is maximum of 15. Next field is total length. It indicates total size of the datagram including header. It is 16 bits long. So maximum size of datagram is 2 power 16, which is equivalent to 65,536 bytes. Okay. One thing, keep this in mind. This 65,536 bytes included 20 bytes of IP header. Next field is service type. It is 8 bits long. Actually, it is rarely used. It contains some information like it tells to machine whether you want some special kind of service, like whether you want to give higher priority to your packets. If you give your packet higher priority, then your packet will route it first. Actually, not all routers support this feature, so it is rarely used. Next field is time to live field. It is very important field. It is also 8 bits long. It has a maximum value of 2 power 8 minus 1 is equal to 255. What this field contain? Suppose in a network a packet is flowing. Normally what we want? We are giving destination address at the packet and we want the packet to reach the final destination. But so many things happen in the network over time. Some links might go down. Some nodes might get down. Sometimes the routing table might get collapsed. So what might happen? Instead of going in the right direction, the packet might accidentally going in the wrong direction. And what worst happen with packet? It might cycling in the indefinite loop. So avoiding this situation, what we do? We set some initial value in this field. For example, we set the value 25. When the packet moves from one node to another, the time to live field decrement its value by 1. 24, then 23, then 22, and so on. And when this TTL time to live field reaches to 0, the packet is discarded. This is time to live field which decides how long this packet can live in a network. Next field is protocol field. It is also 8-bit long. It is used to know which higher layer protocol you are using, TCP or UDP. Next field is source IP address, which is 32 bits long, which contains the source address, means address of the sender. Next field is destination IP address. It is also 32-bit long, contains the address of the destination. Next fields are identification field, flags and fragment offset fields, which are used in fragmentation. Whenever IP fragments the packets into smaller packets. And last is options. Already talked for optional header. This optional header field is required when router supports some special features. Next is header checksum field. It is 16 bits long. Whenever you transmit a packet, there may be some error in transmission, like some bits corrupted. 0 gets 1 and 1 gets 0. When a node receives a packet, there are some mechanism to check whether the bits are correctly received or not. This header checksum is used for this purpose. This checksum is computed only on the header. Whenever a packet is received, this checksum is computed automatically by hardware. And computed checksum is compared with received checksum and check whether they are matching or not. If matched, it is fine. If not matched, the packet is discarded. So this is all about IP datagram. Let us talk about viewing IP packets. There are number of software tools called packet sniffers to view these IP packets. Any kind of packets, not only IP packets, that are flowing through the networks, you can view using packet sniffers. Install these packet sniffers on your computer or server, anywhere in the network. And whatever packets are flowing towards networks at the network interface where you place the packet sniffer, you can see all these packets and get information about packets. These are some popular packet sniffers: Wireshark, T-Shark, WinDump, TCPDump, and many more. We will give demonstration of these packet sniffers in coming lectures. In this lecture, we covered some concepts of TCP/IP. In the coming lectures, again cover some more concepts of TCP/IP, because you see, entire internet is based on TCP/IP. So unless you have a good knowledge of TCP/IP, it will be really difficult to understand advanced concepts of cybersecurity. Thank you.